Good morning, this is your Stat Sensei, Mr. Sensei, and this is a chi-squared test of independence assignment. This scenario is work-life balance. A human resources consultancy firm is investigating the relationship. As soon as they say relationship, I think, hey, this could be chi-squared test of independence. All right, because relationship, independence, dependence, association, those words indicate it could be a chi-square test of independence. And the fact that I see a table pretty much confirms that fact. All right, between work-life balance and job satisfaction. Well, right there, they just told me what my two variables are: work-life and job satisfaction of employees in the US. With the rise of remote work and flexible hours, they wonder whether employees who have a better work-life balance are more likely to report a higher job satisfaction. The firm randomly surveys a random sample. This set should say random sample. It doesn't, so I'm going to write it in because it needs to say that random sample. Also, there's a typo here, and it shows up in the table. Random sample should be of 1,550. So this is not 1,500, it's 1,550. I'm going to go ahead and make that change in the table because it's wrong here as well. So 1,550. From a diverse range of industries, participants are asked to rate their work-life balance as good, average, or poor, and to rate their job satisfaction as high, medium, or low. So for job satisfaction, we have one, two, three levels. For work-life balance, we have one, two, three levels. So we have a 3 by 3 matrix. So rows equals 3 and columns equals 3. Remember, we don't count the totals. At alpha equal 0.05 is there's evidence that work-life balance affects job satisfaction. In other words, is there a relationship? So let's go ahead and flip over and take a look at our actually take a look at what we need to fill in here. And let me get another sheet of paper to do that with. Okay, so there's our information that we were talking about for the scenario recorded in the table. I'm going to go ahead and make that change that I just said that's 1,550. That was done incorrectly. Our formula is the same as it is for all chi-squared tests. Chi-squared equals um, observed minus expected squared over expected. We go to draw our graph. And we go from 0 to positive infinity. And somewhere out here, we're going to have a chi-squared value, and we'll have to calculate that chi-squared value, and we'll also have a p-value, and we'll have to calculate that. Let's go ahead and do our degrees of freedom since we know how to do that. It's rows minus 1 times columns minus 1. Well, in our case, that's going to equal to 3 rows, 1, 2, 3 rows, minus 1, and columns minus 1, 1, 2, 3, columns minus 1, 3 minus 1. And 3 minus 1 is 2, and 2 times 2 equals 4. So degrees of freedom equals 4. All right, we have everything we need to plug in because we have our observed, but we don't have our expected. So we have almost everything we need to plug in. So we need to go ahead and run this thing. So the first thing we need to do is enter our observed values. So blue button matrix, arrow over the word edit. You know what? Let's do this by hand first, real quickly. We'll do one by hand. We're going to go 650 times 550 and divide by 1550. So row total times column total divided by total total. And you can do that with any one of them. 650 times 550 divided by 1550. And we get 230.6. And I'm going to stop it rounded right there at 230.6. And if I wanted to do another one, maybe I chose to do this one. My row total is 550. My column total is 450 divided by total total. So 550 times 450 divided by 1550. All right, and I get 159.6. I know I could round up, but I'm not going to. 159.6. All right. Oops, I put that in the wrong spot. That goes here. 159.6. All right. So let's go ahead and do this where we can do all of them at once. We're going to go to the matrix. I'm going to go blue button, matrix. All right, which is right here, that button. And an arrow over to the word edit. Press enter, and we have a 3x3 matrix. So 3, enter, 3, enter. And we have 350, 200, and 100, 150, and 50. You know, I've typed those all in, so I'm not going to do it again. I'm just verifying that I don't have any mistakes. I don't. So I'm going to blue button mode. And then I'm going to go stat test, scroll to chi-squared. We want chi-squared. We don't want the goodness of fit. This is a chi-squared test of independence. This is only for goodness of fit. We'll press enter, A, B, and we're going to get a bunch of information that we're going to write down. We have a very large chi-squared value of 278.2. And I have a p-value. Ooh, I see an E. That tells me I got 58 zeros. So our p-value, which is right here, this is the chi-squared, is right there. Our p-value right there is equal to 0.000. So approximately zero. So our p-value is approximately zero. And we, now that, I mean, because we have 57, this was a 50 to the 59th power. We have 58 zeros in front. So it's approximately zero. All right, but we still don't have those expected values that we so desperately needed. So let's go ahead and blue button matrix right here. Arrow to edit, drop down to letter B, and there they are. And we say, hey, 230.6, we calculated that. 159.6, we calculated that. So we just need to record those values. So I'm going to try to get those down pretty quickly. So this is 230.6. I'm only going one decimal place. 188.7. 145. Excuse me. 195. What happens when you don't bring your glasses to school? 195.1. 195.1. We already verified the 159.6. And we have a 124.1. A 124.1. And a 101.6. All right, now we can go ahead and plug into our formula. So we have our observed and our expected. So our chi-squared equals our observed value of 350 minus our expected value of 230.6 divided by the expected value of 230.6. And I'm going to go ahead and say this was my observed, this was my expected, and this was my expected. I know it's not much like a 230.6, but that's what it's supposed to be. So 230.6. Hopefully that helped a little bit. I don't think it did. Plus dot, 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 plus. The last one is 200 minus 101.6 over 101.6. All right, inference procedure. Chi-squared test of independence. All right, our hypothesis. We always want to say is independent. So we know the blank and blank variable is independent. Well, what are our variables? Well, let's go back and look at the scenario. work-life balance. So we were looking for a relationship between work-life balance and job satisfaction. So the hoe, work-life balance and job satisfaction is or are, I'm going to say are, independent and now this is interesting. This says are, this is always going to be opposite. So always are not associated. Aha. Work life balance and job satisfaction are not independent. And so this says not here. So that means they're not independent. So that means we're going to say they are associated because they'll be opposites and are associated. Okay, so please make the note there that they're opposites. All right, complete just direct opposites. Conditions. I know this was a mistake, but I tried to correct it. Random sample of 1,550 given. 2, we needed to check to see whether the sample was too big. So we have to take 1,550, multiply it by 10, and equal 15,500. Well, we need to find out what our population size is. So let's go back and look. The firm 15 employees from a diverse range of industries. Well, if we're talking about a diverse range of industries, even though it doesn't say the population, how many people work in diverse range of industries? I'm going to say millions is less than millions. All right. So even though it doesn't have it, and it should, diverse range of less than millions, we can say N is less than 10% of the population. All right. The third one, is our sample big enough? All expected values are greater than 5. See table above. And when we check our table, our smallest one is 101, and we needed it to be 5. So definitely greater than 5. Probability statement. Well, the probability that our chi-squared is greater than, and this will always be greater than, and we've got greater than 278.2. Just pulling it from the graph we made, equals, we said our p-value was approximately 0. So equals 0.000. So our p-value is 0.0000. Our alpha was 0.05. That's a very small p-value. That's getting rejected. We're rejecting the null. So now we can go ahead and write our conclusion up. So our conclusion is our p-value is approximately 0, which is less than our alpha equal to 0.05. We reject the null. All right, we have plenty of evidence. There is sufficient evidence to suggest that work-life balance and job satisfaction are not independent. All right. So all I did right here was restate our alternative hypothesis. As soon as we got to work-life balance right here, that's our HA. And look what it says. Work-life balance and job satisfaction are not independent. Work-life balance and job satisfaction are not independent. So in other words, they are associated. All right, I hope that helps, and I look forward to seeing you on the next one. Thank you.